Hey everyone, um, thank you for coming to the talk, and thanks to our speaker Arman for coming to give us this talk. So Arman right now is an assistant professor of computer science at Yale University, and he's also a faculty researcher at Allen Institute of AI. His research focuses on a wide range of topics, but majorly he's going to talk to us about advancing LLMs and with an interest towards scientific reasoning. So without further ado, I'll just hand it over to Arman and let's hear from him. Let's welcome our speaker.
Yeah, thanks, Tommy. Thanks for inviting me, and glad to be here. So today I'm going to tell you a little bit about some of our recent works around this type of evaluation of non-verifiable tasks in science, and like what kind of insights we can get for like evaluation in these domains, and also like what type of insights we can get in generally like around scientific reasoning. Um, so to motivate this a little bit, like LLM-based systems are now increasingly being used in advanced workflows, and most of these are non-verifiable free-form outputs, where like yeah, just verifying a short answer or like a rules-based system is not usually enough for this type of things. And usually, what people do in these domains, as many of you are familiar, people use just LLMs to evaluate the LLM's output. And they call this like LLM as a judge or LLM critic models or things like that. And there's a whole literature on like how to design better judges. Like people use single LLMs, multiple LLMs, or kind of collaboration setup. I borrowed this figure from this survey that like goes through all of these details on how these LLM judges are designed. Um, so what makes these open-ended tasks like challenging to evaluate? It's usually like harder to verify for correctness. What people do, they usually come up with a set of rubrics, but even then, like the rubrics can be subjective, and like if your task is more complex, the rubric might not be exactly reflective of the final quality that you want. There's other problems like when people use LLM judges, there are a lot of like robustness issues that have been documented in the literature, and their performance can be very variable across different domains. So people usually evaluate these LLM judges themselves as well, which is called like the meta evaluation. And these meta evaluation studies are also very difficult and costly. Um, and then at the end, like when you do this type of meta evaluations, there's not much insights on like general capabilities of models if you are, for example, a better judge than another model. So hopefully in this talk, I'm going to tell you a little bit about some of the work we did to address some of these problems. First, I'm going to tell you about SciArena, which is a work on evaluating literature-grounded scientific tasks. Then I'm going to tell you about how this type of evaluation for assessing LLM judges can be extended to evaluating LLMs as generators. And finally, I'm going to tell you a little bit about our work in kind of dissecting the roles of knowledge and reasoning in scientific problem solving. By the way, if you have any questions, please feel free to interrupt me at any point. I prefer to keep this interactive. And yeah, it's since this is full screen, I probably won't be able to check the chat, so just interrupt me. And
Yep, I can take a quick look at the chat if anything comes up. Yeah.
okay, sounds great. Thanks. So the first work is going to be presented at NeurIPS is SciArena, which is an open evaluation platform for evaluating LLMs in scientific literature tasks. So as an introduction, like like for example, if you want to use LLMs for scientific tasks, and if you don't give them access to search, they usually are not gonna be very helpful, especially if the knowledge that you ask them is not in their parameters. So what people do these days is usually these kind of deep research systems or like RAG systems that allow the LLM to search for the information that it needs and then answer the question. So the type of tasks that you see in like literature retrieval and analysis usually looks like this. Like the output is like a kind of a report. It can be a short answer, like one paragraph, or it can be as long as like multiple pages. And then usually the LLMs kind of provide citations, so you can basically go and verify if what they are saying is actually reflective of the citations. So this is kind of nowadays a standard type of output that you might get from an LLM that is designed for doing this type of research tasks. And then you can inspect and use the output. However, evaluating this thing is usually not very straightforward, as you can see, like this can be very long, and there might be citations that you need to verify and things like that. There has been efforts to create benchmarks for this type of tasks, but usually they're very small and then they are kind of fixed. So they can get outdated very quickly, especially as these models are trained on more and more data. And then it's going to be confounders on like their performance. If you use LLM as a judge to kind of evaluate their outputs, since these are non-verifiable, we will have the same issues that LLM as a judge methods, but we don't have a way to evaluate how good they are on this type of tasks. So in this work, SciArena, our goal was to address these challenges. So it includes a platform which allows pairwise comparisons of models and creating a leaderboard as a result of these pairwise comparisons. And finally, using this human collected data, we can use that to evaluate LLMs as a judge to know if they're good or capable of evaluating outputs in this type of scientific literature tasks. So I'm going to talk about each of these. So SciArena is actually publicly available. If you haven't seen it, it looks like this. Basically, the user issues a query. Sorry if this is too small, but basically it can be any query like how do structured prediction models handle sequence labeling tasks in NLP. Then basically it gives you two outputs with references, and then the references are actually from Semantic Scholar, so you can verify them. It doesn't hallucinate the references as opposed to some of the other models that are out there. And then what users can do, they can basically select the model that they prefer, or like they say, like both of them are good or both of them are bad. And then over time, like when you collect these votes, similar to Chatbot Arena, you can get a leaderboard out of these comparisons. So to tell you a little bit under the hood what's happening, we use kind of like a fixed RAG setup that is specifically designed for scientific tasks. And this involves like a simple query validation setup to make sure that the query is scientific. Then we have query decomposer, which rephrases the query. It extracts some other subqueries out of it, and then it issues these into search APIs for Semantic Scholar. And importantly, in addition to just abstract search, it also does a full text search, which allows us to get more detailed information. And then these are fed into a re-ranker, and then we select the top 30 retrieved passages and then give it to the LLM. And then you might ask, why 30, why not 50, why not 100? In initial experiments, we did a little bit of hyperparameter studies and found that like 30 is kind of the sweetest spot. Like if you go beyond 30, some of the models that we test may go out of context. And also with more passages, it seems it's more difficult for the models to aggregate information across so many papers. And then once we have this RAG setup, we sample two models, and then we basically allow them to process the response. And then we unify the format because like each model processes the output differently. And we kind of remove markdown and unify citation styles and so on. And the output is just this pairwise comparison that you see. Importantly, our goal here is to evaluate LLMs as a component of this kind of RAG setup. You could imagine other type of RAG setups that are not like this or like designed in an iterative way or different styles. We chose to evaluate LLMs as a component of these models, as opposed to evaluate end-to-end on how you can design the full RAG system or full deep research systems. Cool. So we did initial data collection using domain experts, which were like about 100 graduate students across different fields, including engineering, natural sciences, healthcare, and humanities. And the type of questions we collected were these categories. They were pretty broad, from conceptual explanations, questions about the state of the art, challenges and limitations about something, problems, and like kind of findings about papers or detailed questions about some concepts. And then again, like once we have these individual pairwise rankings, we can just basically get a leaderboard by aggregating these through ELO scores using Bradley-Terry models. So the result is basically a living benchmark that allows us to do blind comparisons of the models. It is pretty scalable, and then it's community driven. And it's open, so if you have a task, you can basically just, or if you have a question, you can basically use it to get your response. The good thing about it is it is pretty fast, so you can get a response to your question in like 30 seconds or 20 seconds. Whereas with something like deep research, you need to wait for like many minutes. So let's see like how the models perform in this type of tasks. When we published the paper on arXiv, this was the results. The O3 model was predominantly better than all other models. This was followed by Claude for Opus, Gemini 2.5 Pro, and DeepSeek R1. And I'm going to come back to why O3 was much better, because this was also very surprising to us that like, are we sure that like O3 is this good compared with others? And we actually saw the same thing when we looked at the fine-grained categories. So these are different disciplines and performance of models across those. Again, like O3 is the best across everything, especially in engineering. In engineering, like you see hugely different performance. If you ignore O3, then you can see here that like there are other models that depending on the domain, you get different performance from different models. For example, Claude Opus works well on healthcare engineering, but DeepSeek R1 works better on natural sciences. So this type of fine-grained categories allow the community to get better insights into performance of models on different domains of science. So as you observed, O3 works pretty well, but we wanted to know what's going on and why it works well. So we did some deep investigation and did some data annotation. What we found was that annotators usually found the output of O3 to be more detailed and more accurate. And it basically reflected the cited paper's content much better than other models. And these were mainly the reasons that caused annotators to prefer O3's output. Okay, so we did some study on like basically measuring other types of biases that might impact annotators. This is following like other like kind of arena style evaluations that you can basically uh, add other variables into the Bradley-Terry model, and then basically things like token length or style or citation quality, things like that, to see what is the impact of uh, other features. So compared with existing platforms like Chatbot Arena or Search Arena, these are on the left side. Basically, those have kind of the users have a bias towards longer response and more citations. Usually, users prefer output that has more citations. And then users apparently for existing uh, platforms do not really care much about the citation quality. Whereas in SciArena, we see much less influence by these external factors such as response length or number of citations. In addition, we found our users to be pretty sensitive to the citation quality and elaboration on citation explanations, which is actually what we want in science, that people are usually critical on how a citation is used to support the answer that the LLM provides. So this is a platform and like basically the leaderboard. Yes, there's a question.
Yeah, just a quick question. So, is that difference mostly because of the uh you have an expert annotator versus I think some of other right now there was more like general user, or is because of the type of problems or the prompt that you have causing that difference?
Yeah, that's a good question. I believe that the reason is mostly that like these chatbot arena and search arena have like wider users that like basically it could be anyone. But most of our users are, we assume, are like scientists or researchers who really want to get value out of this. I think yeah, it's the user base that is different. Yeah.
Okay, yeah, and also have another question. So is do you also have a notation to see that is comparing all these model, would their answer more precise or more correct versus that it has a better format? Like, is there a difference that sometimes some of the model would maybe hallucinate or give a wrong answer versus yeah the generated answer is more complete and then more easy to understand.
Oh, you mean in terms of the style
Yeah, I
of
mean, yeah, when they do the rating, yeah, do they like rating more on the accurate of the answer, or do they rating more on the the style or others factor?
so we didn't do that type of annotations, but there is a field that users can provide the reason why they chose one answer versus the other. And for about 30% of the responses, we actually have that rationale that users provide. We just haven't done analysis on it, but the
Okay,
data is public, yeah. If
okay,
you
thank
thank you. Yeah.
I also have a question. Is I think maybe I missed that, but what is something this arena can do that the other chat, for example, chatbot arena, as it stand, cannot do? In the sense that, say, if you in both cases you recruit your evaluator, your user, so you have the same set of user. So then the same set of user could have get on chatbot arena doing the same task,
Uh,
right? I know you have a retrieval component, but arguably many at least closed source model, they probably have built-in retrieval as well. Yeah, so I was just trying to understand like the design principle and what makes it different.
yeah, that's a good question. So basically, we wanted to know like what is the performance of models to like if they're given the fixed context that is the result of a fixed retrieval setup to isolate the performance of like different search kind of pipelines that models might have. For example, you might, I don't know, for example, OpenAI deep research might use a more complex retrieval setup down the hood, and then it gets better results. Then we don't know if like the LLM itself is better at that task or not. You could argue that like maybe the users might not care at the end, like that they might care about the end output, but our kind of hypothesis or like design choice was we wanted to isolate the performance of models from the retrieval as a kind of a separate capability evaluation of models on how they can handle this type of tasks, especially when they're given many sources, information from many sources, if that makes sense.
Okay. Yeah, that does make sense. Do you have any comparison or evaluation against, for example, deep research style to understand how, for example, you can, although I think it's not completely because they don't give you the information. On the other, like flip side, you can also evaluate the impact of the retriever if you know the exact language model they use in those deep research model. I think both OpenAI and Gemini have, and then like their complete age agentic framework versus your thing with your retriever and language model sort of dissect a little bit. I wonder whether you have those comparisons.
Yeah, that's a good question. We did a small kind of a study just because these deep research systems are very expensive. And then what we found was that their outputs are much longer. It goes to pages, and then it becomes it is too long to kind of have a fair comparison with our output. And also, yeah, for that reason, we didn't continue that kind
I
of
see.
systematic evaluation.
That makes sense.
And also,
And then one last question, since you mentioned the length, that actually we have been doing quite some of these evaluation of systems, and then we constantly face the issue of those different models, they produce different length
yeah.
as output. Do you sort of doing some of it length how to say the what do they say, the length regularized or whatever controlled comparison or what?
Um, yeah, so what in the prompt we try to ask the models to like kind of give the same type of length, but also our annotators basically are not as biased on length, especially like the annotators that we recruited. Like we
Mm,
specifically instructed them not to be influenced by that. Uh,
okay.
but yeah, for the public data, definitely, yeah, that we will use the like the for the leaderboard, we are using the length control.
Okay. Thank you.
Thank you.
Hi, can I also ask another question? It's like a
Sure.
follow-up to the yeah, so about I'm curious, is there a specific standard provided to the users to judge their preference? Like, is there a specific rubric for user preference? For example, do they prioritize factual accuracy or helpfulness, or are they like asked to specifically favor shorter answers, or is it only based on their own judgments?
It is based on their own judgments. We just have some guidelines for them not to pay attention to the length, yeah, these stylistic differences.
I see. So it would be based on their own domain expertise. And
Yes.
it would be okay, and there's no difference among the domains. Like in terms of what you told the users.
Oh, domain-specific instructions. No, we don't have domain-specific instructions.
Okay. Gotcha. Thank you.
Hi, I just wanted to ask a quick clarification question, going back to Kaiwei's question, where it seems like the results you had comparing chatbot arena and the other more general arenas to this one were aggregating across all the users. And I was wondering if you're looking at how closely the user in SciArena, how closely the user's expertise matches the text that they're actually evaluating. If you had any analysis of that sort, breaking it down and seeing if you see similar differences.
Yeah, I don't think we have done any of that for the public-facing leaderboard, but for the initial data collection that we did and resulted in our study, for that, users actually are, yeah, they're only evaluating things that are under expertise. So,
Okay.
but for the public interface, we actually don't collect users' information, so it's hard to know. I would say. Yeah, good question. Cool. Moving on. So basically, now that we have this pairwise comparisons, what we can do like meta-evaluation studies to know if LLMs can do this. And this is basically comparing the correlation of human judgments with like LLM judgments. And yeah, you can see the results here. Basically, 50% is the random guess. And then what we see is that like O3 model is the best, but it's still there is like a large gap compared with human agreements on like which output is the preferred one. We do see some like biases as other people also have reported. For example, there's this issue of self-consistency. Like if you're using, for example, GPT 4.1 as evaluator, and then if you swap the model orders when you're asking it which one is better, you only get 70%, around 70% self-consistency. And then 30% of the time it kind of flips its decision. So this is also something that other meta-evaluation papers have reported as well. And then there's always some bias towards predicting the second model when you use an LLM as the evaluator. So this is the current leaderboard status. I took it, I think, last week. And it is still O3 that works much better than others, although now we have Cloud 4.1 Opus and GPT-5, which are closer to it. And then you can see the rest of the performance here. The leaderboard is live, so you can go and check if you're interested. So basically, we will be adding new models as they come out. So far, we have 35 strong models, and then we have more than 3,000 votes. I think the number should be about 4,000 right now. And then it gives us, this type of data gives us insights into how these models can be used for this type of scientific tasks. And the data and like the rationales of why people select one vote versus the other are all public. So if you're interested to do some analysis on this, the data is all there. Oops, I think, okay. So just to wrap this up, SciArena is an open platform that is expert-led, and it allows us to do better evaluations of LLMs as a component within the like broader RAG or deep research systems for science. And what we find is that models perform differently on various domains, and reasoning models usually perform much better. And we found that LLM as a judge is not very reliable in this type of tasks. And yeah, some common failures on models is that like we observed, or our users observed, that the models sometimes they just go on and talk a lot about other things and they do not answer the question directly. Sometimes they cite lower quality or contradictory evidence. And sometimes there's not enough methodological detail, or they misuse the knowledge to kind of yeah, say something that is kind of like a soft hallucination. So yeah, this is this part. Any other question before I move on to the next? Cool. So this work is kind of a different flavor. Is basically some insights on how we can use LLM as judge evaluation to see if we can evaluate LLMs as generators. And this is going to also be presented at NeurIPS. Um, so usually, like just to give people some background in case they're not familiar, LLM evaluation in non-verifiable tasks is basically done by correlating them with human judgments. And there are data sets that are released with human ground truth preferences. And these are things like wild chat, SciArena, and things like that. Sometimes these ground truth preferences are obtained from a strong LLM and are not human annotated. So things like Alpaca-Eval that people evaluate on, for example, uses, I think, GPT-4 or GPT-4o as the evaluator. And then basically this type of evaluation is done to evaluate how good an LLM is in generation. And then you get this type of leaderboards that people kind of report on, and like things like Arena Hard or Alpaca-Eval. And yeah, these are used for evaluations for papers. At the same time, LLMs can be evaluated as judges, or how good they are as evaluators. So this is also done through kind of meta-evaluation studies where like you have human ground truth judgments where humans like you specify their preferences, and then you have an LLM as a judge. It provides its preferences, and then you just do correlation. And then the meta-evaluation is basically saying if I get an output ranking of models or judgments, and then if I get an evaluator ranking, how well that evaluator ranking compares with human rankings that I get. So the key question we want to ask in this work is, if an LLM is good at generation, is it also better at evaluation when you're comparing across different models? And we call this generator-evaluator consistency, or GE consistency, which is the correlation of LLM's performance rankings when evaluated as generator versus evaluator. So on the left side, you can see the generator ranking. For example, you have an instruction input to different LLMs. You get the responses, and then using a preference oracle, which is usually like an LLM. People use this to get the generator ranking. And then on the right side, you can do the same thing, but evaluating LLMs as evaluators. Here you have a pair of instruction and response, and then you have multiple LLMs, and then you compare the responses that you get from LLMs, and then you compare those judgments with preference oracle, and then you get a ranking, and then you compare how close these rankings are. This is a bit different from other studies that have looked into this problem. There are other studies who have looked, for example, on self-consistency of LLM. For example, if an LLM is generating some text, does it also prefer its own output versus other models? So you might ask, why do we care? What is the implication of this thing? So the implication is that if we use if we find that the generation evaluation consistency is high, then the LLM alignment in general can be evaluated by evaluating LLMs as judges. And we don't need to evaluate new LLMs outputs anymore by judging them through Oracle. So I'm going to unpack this a little bit in the next few slides. So how do we do this? Basically, we construct a controlled setting. We use a strong LLM like GPT-4o as a preference oracle. So this gives us basically the votes on like which model is better, which model output is better. And then the input instruction set is, we take it from existing data sets, Alpaca-Eval and Arena-Hard. And then we choose 15 LLMs to evaluate. And it's important that like these LLMs are not as strong as GPT-4o because we want the oracle to be strong and be able to differentiate between the output of other models. And then we compare the outputs against baselines using the preference oracle. And then we do two orders. Like we also reverse the order to kind of eliminate this position bias that exists for LLM judges. For the evaluator, which you can see on the right side of this, we basically take evaluation task instances, which is pairwise comparisons of LLMs versus a baseline. And then for baseline, we use GPT-4o. And then we just compute the inner annotator agreement between the LLMs and the preference oracle's evaluation results. And then importantly, we remove instances on which the preference oracle is inconsistent with itself. So if you kind of swap the order, if it changes the vote, we kind of we eliminate that instance from our analysis. So this is the result on like how do the LLMs kind of exhibit generator evaluator consistency. We see that the consistency is high, especially for the Arena-Hard dataset. We see 0.97 Spearman correlation, which means that the LLM that is better at generation it is also better at evaluation when you are comparing it with other models. And then this consistency filtering turns out to be important to get this high correlation. If we don't eliminate these type of inconsistent instances, we will get about like 79% at the best case, whereas with filtering, we get 97. Okay, and then
Sorry, can I ask a clarification question real quick?
Sure.
Maybe I misunderstood the pipeline, but so you mentioned self-bias, but I was wondering, since you're using the strong GPT-4o as the preference oracle, isn't there a problem of self-bias when the strong model is evaluating models from the same family, so that maybe it'll prefer the model from its same family more?
Yeah, that's a good question. So the models that we are evaluating are mostly open source or kind of weaker models than the GPT-4o. We wanted to control for that. So if you're like you're using GPT-4o as a preference oracle, we do not evaluate GPT-4o as a generator.
Thank you for that.
Yeah. And then GPT-4o itself can have this self-inconsistency issue that it might prefer the second output. So we also remove those instances where it is inconsistent. Cool. So then the next question was like, if related to Inge's question, if we replace GPT-4o with other models as preference oracle, do we still see the same performance, same GE consistency? And the short answer is kind of no. Like you basically need a strong model to be able to get high GE consistency. However, like with 70B models, you can get still above 90% GE consistency. So this suggests that basically if you use a GPT-4o, which is a strong model at the time, basically you can get high GE consistency. So again, like, why do we care about this? Because we want to kind of have a new paradigm to evaluate LLMs in non-verifiable tasks. And we do this by evaluating LLMs serving as judges. So basically here, if we get the evaluator ranking by evaluating LLMs as judges, then we can approximate how good they are as generators. And this is kind of, we show that this is kind of comparable with benchmarks that use LLM as a judge to evaluate generation capabilities. And we call this benchmark, kind of benchmarking paradigm, Align-Eval, which evaluates LLM serving as judges. So the data instances, importantly, we can reuse the evaluation task instances that we obtain, and then we don't need to generate them again. And then instruction set, we take it from an existing data set, the Arena-Hard, and then for preference oracle, we use GPT-4o or Claude Sonnet, which were strong models at the time when we were doing the experiments. So what's important is that Align-Eval does not require evaluating the LLM outputs by an oracle. So for example, let's say you come up with a new model and then you want to evaluate it. You don't need to send the output of your model to GPT-4o for evaluation anymore. So that's why you see that the cost of evaluation is going to be zero in terms of like API costs that you would need. And this is actually makes evaluation much more efficient. So we wanted to see if this kind of benchmarking paradigm can be good in terms of quality compared with other models. So we basically compared with LLM judge-based benchmarks, things like Alpaca-Eval, length controlled, and Arena-Hard style controlled. And then also GPT-4o as a judge on Arena-Hard instructions. And if you're not familiar with how these data sets are constructed, what they do, they basically, they have shown high correlation with chatbot Arena, which is user votes. And then they show that like if you replace the judge with like a GPT-4o model, you can get high correlation with chatbot Arena. And then therefore, this is a good benchmark. We also compared with if-eval, which was this benchmark for instruction following evaluation with verifiable outputs. And we compare with mix-eval, which approximates user instructions using existing benchmarks rather than generating new outputs for each model. And then help steer 3 is a data set that already has human judgments. So here's the results. We can see that our benchmark in terms of correlation with chatbot Arena is kind of competitive with Arena-Hard style control and GPT-4 as a judge. And then it's important to know that these benchmarks all use an LLM to evaluate the model's output. whereas align-eval does not use that. Compared with benchmarks that do not use LLMs as judge to evaluate the output of each LLM, we see that our benchmark gets higher correlation. And then the correlation of if eval is also quite high compared with like chatbot arena's correlations. So we did a bit of investigation into this, and what we found was that like align-eval essentially evaluates the content on whether the LLM understands what is required to answer the output. However, if eval is mostly on following instructions, whether, for example, the length of the instruction is correct or like whether the style is correct or not. So we thought, why not combining the two? Like if eval is evaluating the style and align-eval is evaluating content, maybe we can average the two. And actually, we could see that align-eval-plus was able to get much higher correlation by combining the two. So the key takeaway, like I know there was a lot of like details on how this study was done, but the key takeaway I hope people can take is basically the LLM evaluation, the LLM evaluation capability can be another dimension that should be studied more, and it might have broad implication than just ranking judges, because we could use that to design other benchmarks or evaluators to know if models are generally good at alignment. And it helps with more efficient evaluation by reusing the model outputs, and it has high correlation with human rankings on chatbot arena. So I don't think I will have the time to cover the third work. So maybe I can just, stop here. If people have questions about the third work, I can talk offline. And then, let me just go to the last slide. Thank you all for attention. And I wanted to thank my students and collaborators as well.
Awesome. Thank you so much for the talk. And I'm happy that people were so interested that we couldn't reach the third work, but we would love to know about it some other time.
Yeah.
I think for now, let's take some questions. We have time for a couple of questions. So anybody who wants to ask can just speak up.
Can I also another, maybe not question, but an open-ended question or discussion? I feel like there's also another aspect of implications of evaluating LLM alignment with human ground truth, which is in terms of generative verifier. If we want to, we see that people use LLM as generative verifier to as maybe reward model for themselves, for their own generations, and for self-refinement. So if models are having great performance in alignment, then this means that they could also have better performances in this aspect. That's my comment.
Sorry. You mean like if the model has a good alignment score, is it also a better judge? Is that?
Yeah. So if they are better evaluators in aligning with human ground truth, is that what you're implicating in the discussion slide? Or maybe
yes.
if I.
The implication was if you get like better alignment. So let me go back to that slide. So basically, if you get better alignment here, like if, for example, the ranking you get for generators is basically similar to rankings you get from evaluators, then it means that like if, for example, let me show you a very concrete ranking. Like here, like on bottom right, you can see, for example, a ranking of models. And this is what Arena Hard, for example, reports at the time. And then here they observe that GPT-4 is better than than Claude, than like Llama. And then if you do the same thing, but evaluate these models in terms of evaluation capabilities or like judging capabilities, and you get the same ranking, then it kind of shows that maybe you don't need to do this type of evaluation. You can do the evaluator evaluation, and then you get the same kind of results, if that makes sense. And then the good thing about this is that, like, for example, here, if you want to evaluate a new model, like let's say GPT-4 comes out, then you need to generate the output for all the instances in the dataset, and then compare that output with the baseline model using an LLM judge. And then based on the win rate that you get this score. Whereas in our benchmark, we don't do that. And so we don't need to compare calculate the like the quality of the output of this using a LLM judge. We can reuse the output of other LLMs as judges, and then basically use that to get the rankings.
I see. So this is more of an aspect for, but are we sure that there's a high correlation? This is based on the assumption that there's a high correlation between the generation and evaluation capability. So the
Exactly.
G consistency.
Yeah, and then
I
this
see.
is why, like, we observe, like, if you use this data set, like Arena Hard as instructions, you get like 0.97 correlation. But yeah,
I see your point. So this is more like a efficient and a new novel way of evaluating LLMs.
exactly. Yes.
Thank you.
Cool.
I had a related question to this. So is there a risk that some model that people are training, like they post-train it on like being an LLM as a judge and like boost that specific performance and like get better score on this benchmark?
Uh, there's always that risk that like people game benchmarks. I think this is kind of like the Alpaca eval and this type of benchmark like Arena Hard that you see. People like usually academic community evaluates on that. For example, people who come up with a new DPO model or GRPO or stuff like that, they usually report results on Arena Hard or Alpaca eval as well. But like frontier like model developers like GPT-5 won't evaluate on these. So I don't think that would be a concern for those. But like I could imagine like academic community can also game some benchmarks or like um, I wouldn't say game, like maybe they tune their models towards that, or that's always a risk, and yeah, which exists with all benchmarks.
Okay. Thank you so much.
Awesome. So yeah, we're towards the end of the call. Let's thank our speaker again. Thanks, Arman, for this wonderful talk and enlightening us about your works. We have 2 student talks after this for the next hour. So we'll just use the same Zoom. So the students who are joining in, you can just sign in back to the same Zoom and talk to Arman about it. I'm just gonna end the recording meanwhile.